In this slide, we are going to see one of the most important policy response, which is called mitigation. In mitigation, there is policy response to the risk of transition. So basically, mitigation refers to actions that reduce emissions of carbon dioxide and other greenhouse gases, and it, as a result, prevents the climate from changing. In the present energy system, most of the energy comes from burning the fossil fuels. So the amount of carbon dioxide produced per unit of energy generated is known as carbon intensity. The highest carbon intensity fuel is coal, followed by oil and then natural gas. So the purpose of mitigation is to reduce this intensity and move from high emitting fuel to less emitting fuel. Now, beyond reporting organizational GHG emissions, the understanding of carbon intensities or emission factors is very important in any energy or policy related discussions. Now, this mitigation cannot occur all of a sudden from high emitting or high GHG emission emitting to less emitting fuel. It can also be a step by step process. So, it can be a change from a coal to gas, or this is also known as a bridge to help the countries in transition to more clean energy. Then there is another phenomena which is called methane leakage. So it is the escape of methane during extraction or transportation of natural gas, which has come into prominence as the use of natural gas is being advocated. So it comes with the inherent risk of leakage of methane. So in order to solve this climate change occurring out of fossil fuels, we need to adopt more climate safe energy sources that do not release carbon dioxide into atmosphere. Or for this purpose, we can use cleaner sources like wind and power. Now solar energy is a renewable energy source with most potential. Now, according to one study, to satisfy the human energy needs, it would require 1 million kilometer square to be covered with solar energy collectors. So this is equivalent to about 1000 kilometers on each side, and it is roughly around 0.2% of Earth's surface. This is a very small area comparable to the total area of Earth. But the problem with solar energy is that is the problem of intermittency. This is the same problem which is also with the wind energy. Now, wind is very important and very prolific climate safe energy source. A single wind turbine can generate as much as 10 megawatt of power. But if we take into account the intermittency of wind, then the energy requirement uh, can be fulfilled with few million wind turbines. Now here we should understand that putting a wind turbines does not prelude using the land simultaneously for other activities such as agriculture. So this is one advantage over solar. Also, wind turbines can be put offshore with an additional benefit that offshore wind typically blows more consistently. So intermittency is less of an issue than for land-based wind. Now, now wind and solar energy has been growing rapidly for last about 10 years, and these are emerging as important contributors to energy supply. And the price of these energy sources have also declined rapidly over last few years, and now they are very competitive and even cheaper than the conventional fossil fuel. in many places. Now, if this trend continues, then wind and solar will become a bigger part of our energy mix. And the primary issue with wind and solar, which is intermittency, that is sun shines only during the day and uh, when it is not obstructed by clouds, and also wind speed varies with meteorological conditions. Now people want power whenever they want to use it, so a grid containing a significant amount of wind and solar has to be balanced with some dispatchable carbon safe energy source. Now with dispatchable sources, we are able to generate energy regardless of weather conditions. Now under dispatchable sources of energy, there comes hydroelectric and nuclear. Now coming to hydroelectric power, it is generated when water runs through turbines, when water falls from dams and it spins the turbines and generates electricity. So it is the mostly used dispatchable renewable energy source in the world, and it provides about 16% of the world's energy. Now, despite having so many advantages of renewable power as an energy source, the disadvantage is that it can cause ecological damage. Then the other disadvantage is that uh, it uh, it has its own problem of its peak availability, as well as when water is available, and when water is not available, then this energy is also not available. Then another significant source of climate safe energy is the nuclear energy. Now nuclear energy is a very mature technology and it generates about 10% of world's electricity. Now nuclear power plants are the problem is that nuclear power plants are very expensive to build, and this is one of the primary reasons that only few new nuclear plants are being built in most of the countries. Also, there is a lot of opposition to new nuclear power plants as it has got environmental risk of that power. So there are issues related to radiation, waste disposal, uh, proliferation, and there has been a lot of instances related to these issues also. One of the solution is or one of the most advancement in the technology related to nuclear energy is the development of SMRs. SMRs stand for small modular reactors. So these are physically very small. So they occupy a very small fraction of the area of a conventional nuclear power reactor. Their modular design allows much of the plant to be manufactured in a factory and transported to the final site. So this offers savings in cost and construction time. Also, SMRs are very simple and than traditional nuclear power plants and are expected to have safer modes of failure. Also, less frequent refuel cycles may ease the proliferation concerns if we use SMRs. So, by using SMRs, many of the technical problems with nuclear energy can be addressed. However, this is a very politically sensitive subject. So, these are the policy responses. Uh, Example for mitigation. So, under mitigation, there has to be policies which will shift energy use from high GHG intensity to less GHG intensity fuels. It cannot be a sudden change, so it can be uh, step by step gradual change also. So from coal to natural gas to uh, wind and solar, but wind and solar comes up with their own problems of intermittency. So for those periods, so hydroelectric and nuclear uh, power can be used.